All right. Welcome back to another thrilling episode of Data 606. We'll talk all right, well, I'm just gonna skip over this. So tonight I'm just gonna get right into it. We're gonna talk about ggplot 2. So this is like part 2 of summarizing data. Um uh, Second to last slide, I have a bunch of links to resources, but this is one of the packages that I use literally almost every day in R to create data visualizations. And it's to me one of the nicest ways that you can make visualizations. I'm going to go through some examples showing we're going to talk about six or so different types of visualizations, which are going to be some of the more common ones we're going to use in this course. But my hope is that as the semester goes and we create more sophisticated ones, that you'll start playing around with it and kind of seeing some of what you need to do. So this is really, you're going to have a whole course on data visualizations, and there's some of this, there's some interaction, there's some theory and stuff that we can't really go into in this class, but at least this, I think, if you start to learn ggplot, and if you end up in the Python world, which is totally fine, I do believe there is a an active port of ggplot to Python, so the sort of same framework notation would apply there. Oh, and there we go. So Zoom thought I wanted to annotate the screen, not click ahead. All right, so this is a framework based on some work published by Wilkinson in 2005. So he wrote this book called The Grammar of Graphics, which outlined this kind of philosophy, if you will, of how you can create data visualizations. To me, it was pretty natural. So when I first graduated as an undergrad and through the dot-com bubble, I actually worked for a GIS company where I did a lot of mapping stuff, and so I kind of this notion of drawing in layers makes complete sense if you think about it from like a mapping point of view. Like if you think about how Google Maps draws things, it starts like at the bottom, right? So you're going to start with polygons and you're going to draw like lakes and land masses and things like that. And then you're going to draw polylines, which are lines on top of it. So things like road networks, rivers, and et cetera, et cetera. And then you could draw, then your point layers on top. So it kind of these generally three types of objects. Now, ggplot, as we're going to see, is got a lot, dozens of object types that you can draw, but this notion that you're going to draw layer after layer is kind of how ggplot works. And then you can make decorations and kind of change settings. Now, ggplot 2 was originally created, well, ggplot was written by Hadley Wickham as part of his dissertation work. And then shortly thereafter, I think ggplot was originally he released it on GitHub for at one point for historical reasons, but then rewrote it, and so it became ggplot 2. If you don't know Hadley Wickham, he's the chief scientist at Posit, sort of pretty prolific contributor to the R community. Um, anyways, he's done a lot of great work for the community. He's also the author of the R for Data Science book, which we recommend for this course, and I think is used for some of the 607 courses. If you have George, I think George uses it. I'm not sure if Andy's using it. Great book. Okay, so ggplot. There are sort of three ways you can work with ggplot. One is by calling qplot, and qplot is designed to sort of be a one-to-one replacement to some of the base R functions. So like in R, there's a hist function, a bar plot, and I will use these from time to time. They're fine, and they're a great quick way to kind of look at data really fast. And so qplot is kind of meant to be like that, but then you get the sort of ggplot look and feel. My advice is don't even bother, because very quickly you're going to want to modify it in ways that qplot won't allow you to do. I think it's fairly limiting. So we're going to focus in on the second one, where we start with the ggplot function call, and then we add on other things, and I'll talk about those other things in a moment. Now, for completion's sake, there is a third way, which is you can start with the ggplot, and then you can just call layer. So layer is technically a function in the grid graphics package. So that package is going to be there because ggplot was implemented using the grid graphics framework. So if you ever find yourself like, I want to do this, but I can't find the geometry type, you can actually create your own geometry types and or do it directly in the grid. I gotta say, I've been using ggplot maybe close to 20 years. I've created, I did actually write my own geom at one point, and that was literally the only time I use this third point. But I put it here just because I want to be complete. So generally, you're not going to do that. If you find yourself in that rare circumstance where there's not an already existing geometry type to do what you want to do, you can do that. So we're going to focus in on the second. So within that second, there's 5 different kind of parts of the ggplot expression. The first 2 are required. You need to have a data and you need to have layers. The rest are optional. And I think a lot of this is going to hopefully become a little bit more clear as we look at examples. But let's start at the beginning, right? So we have this ggplot. The ggplot function is not really going to draw anything. This sets up everything to do the drawing. It defines the data for that you're going to plot and the mapping of the different the different components to the data in the data frame. So AES is a function. It's short for aesthetic, right? So that's what it means. And so what we're doing is saying there are different parts of a map. So if we're talking about a scatter plot, you need to define a variable that's going to be on the x-axis and a variable that's defined on the y-axis. So, what's to the right of the equal sign, it should be a variable name in this data frame, right? And then from there, we're going to add in our layers or our geometries, if you will. So by convention, all of these start with geom underscore. So we have point, histogram, etc. We're going to look at some. Okay, so that's the bare minimum you need to get a ggplot or to generate a figure using ggplot. From there, you could do other things. So faceting is this notion that I want to take this one plot and actually create a whole bunch of subplots. I want to break it up by usually a categorical variable. So instead of one scatter plot, I'm going to have a whole bunch of scatter plots grouped by some variable of interest. And so that becomes really simple this way. We could do scaling. So we'll look at log transformations tonight as one. There are others, but 98% of the time it's a log transformation you want to do. And I'll be honest, I almost never use the scales in ggplot because if I'm going to do rescaling, I'm going to rescale it in my data frame before I get to the ggplot expression. I might just create a new column, which is a log transformation, but I'll show you how to do it in ggplot tonight. And then lastly, there's other options, right? So if you want to give your plot a title, there's a GG title. If you want to change the limits on your y-axis, you can do that. You can change the labels. And so there's a whole bunch of options you can do. All right. So here I'm just doing a little regular expression. So this is in the ggplot2 package. There are 53 geometry types. We're going to learn about 6 or so, I think, tonight. But if you can think it, there's probably a geometry for it. If not in ggplot, by default, in an add-on package. Okay. Here's a link. Like a lot of these things, I try to link to the cheat sheets that Posit provides. This one's a 2-pager. What's particularly nice, I think, about the ggplot is they give you little thumbnails of what like the geometry is. So, I was looking at this one earlier. I was like, oh, instead of a histogram, I want like a dot plot, right? So, I can look up the geom dot plot. And usually what I do is, let me, so I was doing this earlier. So if I could, oops, I would have to load the ggplot2 package, and then I could do geom dot plot, right? And I can get the help documentation. Why is this so slow? Okay, my R session is not cooperating here on this server. So we'll come back to that. Oh, no, there it goes. There it goes. Right. And often what I do is I scroll down to, the examples. You could click this and run all of them, but I'm just going to do one, right? So I can kind of see what's going on. So this is a great way to figure out, what I want. And they have them grouped with, 1 variable, 2 variables, 3 variables, et cetera, et cetera. So anyways, helpful resource, I think. So let's start with some examples using our good old Lego sets data frame that we talked about last week. All right, so let's break this down. So I have a scatter plot. So I have two variables I'm looking at. So I always start with the ggplot function call. The first parameter is the data frame. Where's the data that I'm going to plot, right? And so from there, I'm calling the aesthetics. And so in this scatter plot, I want to put the number of pieces on the x-axis and the US retail price on the y-axis. So these are both variables within the Lego sets data frame. So that just sets everything up, right? This sets up the data. And what do I want to draw? I just want to draw points, right? So I'm doing G on point. And there we go. So I have a scatter plot. But from here, I can make it a little bit more complicated, right? I can add, so there's a whole bunch of, other things other than X and Y. I can define each color by a category, right? So availability is a categorical variable in my Lego sets data frame. We could see here I get the legend. So all I did was add color equals availability. And now I have a scatter plot representing three variables. Um, okay, so Igor's getting, it's in Brickset. And it is on CRAN. So there you go. I put it in the chat. Install that package is Brickset. Okay. I can go a step further. I can add a size parameter, right? So size for points is going to define the size of the point relative, right? So minifigs is the number of little figurines in the data set. So the bigger the point, the more minifigs in the set, the smaller the point, fewer minifigs. Okay. So, and you could see for free, I didn't do anything. I get the legend. So this is to me pretty nice. And I think this is, aesthetically pleasing. Now, if I look at this, right, I could see I have a lot of purple down here, which I think corresponds to retail, right? So one of the problems when you're doing scatter plots when you have a fairly large data frame is that the order that I think ggplot just starts at the beginning and it sort of plots in the order that they occur in the data frame. And so I think these purple points are overlapping points that are underneath. Now I could do some other things, right? So here, I'll throw this R script. So this is, I was teaching the undergrad. I just happened to be teaching the same topic for the undergrad class and the graduate class in the same day. So this is my second time through these slides. So, all right. So here are the names in my data frame, right? And I think I was showing this earlier because somebody had a question. So another way I could handle like overlapping points is in the point, there's this alpha parameter, right? Which is the transparency level. So 1 is completely opaque, 0 is completely transparent. And so I pick 0.1, right? And there's so many points that it doesn't really help. Oh, the other thing I'm showing here is I tend to like the theme minimal. I'm not a huge fan of the gray background. So when I actually publish plots, I use theme minimal. It also, when you print on paper, looks nicer in my view than this gray background. Sometimes the gray I think interferes with contrast. The gray is nice when I teach in classrooms on a projector, which might be why Hadley did it. I'm not sure. Anyways, you could play around. There's a lot of actually things. I digress. All right, scatter plot. Please throw questions in as we go. Okay, so that's what I was saying. I totally sometimes my digressions distract my point. A lot of purple points here, right? Is that because all the retail is there? What about other things? So I might want to do faceting. So instead of coloring on availability, I moved it over to facet. So I used facet wrap here. There's also facet grid. I'll be honest, I use facet wrap 99 out of 100 times. Grid will do a little bit. So in this case, what grid would do is either line them all horizontally or vertically if you want to line them up that way. But I just did wrap, so it's just going to fill nicely. There are parameters like you could specify how many plots per row or per column, right? Depending on if you're printing on paper, if you're printing on landscape versus, landscape is horizontal, portrait, depending on the orientation, you might want to wrap them a little bit differently. Okay, but the point here is I could see certainly retail is down in the sort of bottom left of this plot, but so is retail limited and Lego exclusive. And not only is that, Lego exclusive kind of spans the entire range, right? And then I can also see like Legoland exclusive, not so promote. There aren't hardly any observations there. So where I think color in some circumstances is really nice, I think in this case, there's too many points and the categories are too broad. So maybe doing a faceting gives me a little bit better insight. But the point being, this is all I did to do it, right? I didn't have to create um, 10 different plots here in subsetting. ggplot kind of handled it for me. All right, a plot type I use quite a lot is the box and whisker plot or a box plot. So here I have to do a little hack. On the next slide, I'll show why. So box plots presume you have two variables. You need to specify an X. Usually the X is going to be a categorical variable, but I only wanted one box plot for all US retail prices. So I kind of hard coded a variable. This is just creating it. So you can see on the X, I just have Lego. Don't really do this very often, but I want to show and also explain. If you're not familiar with the box and whisker plot, it's fairly nice, right? Because this line here in the middle corresponds to the median, right? And then the bottom of the box is the 25th percentile. The top of the box is the 75th percentile. So 50% of all observations fall within that box. Okay. So now we have this whisker. The length of this whisker is equal to 1.5 times the interquartile range. Okay. So that box has a certain height. I take its length and then add another 50%. So it gets a little bit longer. And then if there are any observations beyond that, I just do them as points. And the idea here is that these are kind of potential outliers. Now it turns out like the US retail price, this distribution is highly skewed, and we're going to see it in a different distribution. Um, on the bottom, we're kind of doing the same, but then we have a, kind of a floor. We don't have any values less than zero. Um, so we could do other things. So this is where I'll go a little off script here. If I do well, I'll do Lego sets. Um, let's say I'll do I'll just leave X as that constant. And instead of I'm going to use pieces instead of US retail price, and I can do geom box plot, right? And all right, I'm jumping ahead because I can't really see that. I'm going to do scale X. Oh no, I want to scale Y log 10. Okay, there's a little bit of a better box plot, right? So now we could see it. Now I've changed the scale on the y-axis. I'm going to talk about that in a minute. But here's where like layering can be really interesting because I could do geom point and I could say y equals mean of log of Lego sets. What I did pieces, right? And right, and I could say color equals blue and I'll make size equal something bigger. Um Oh, right. I think I need to do the AN.rm equals true because I think there's some missing values. There it is. So the mean is way down here. I think that's wrong. I did something wrong. Maybe I need to do, why is that way down there and not? Oh, I know why. Oh, now it's completely gone. All right. So this is why I shouldn't go off script. So I think it has to do with the log transformation
You
happening at a
you
later point.
you want to log after you get the mean, right?
Shouldn't matter. So it did it there. There's the mean. So I could have the mean and median. So that's a good question. I'm pretty sure. So if I say Lego sets pieces. So if I do log, oh, you're right. It might be the order might be wrong. So if I do this, all right, I need to do the na.rm equals true. Oh, I get negative infinity. Wow, that's a versus log of mean. Wow. I'm sorry about this, folks. I did not expect this. They are different.
The zeros, right?
Yeah. Probably. Oh, right. Because I have zeros in there. Right. So there are actually, yeah, some things that have zero pieces, right? So I need to, so often what I do is add one, and then that's not going to work. So if I do that, then I need to subtract one here, and I still don't get the same answer. All right. I'm going to move on because um I don't like logs that much. Um when do you look at the density plots? Okay, we'll get to that, Denise. All right, here we go. Here's really what I usually do for box plots, right? Now I can look at a box plot for a whole bunch of different categories. Even though I didn't log transfer them, this is still US retail prices, right? I could quickly see educational sets, much more expensive than other categories. There are reasons for that. I think you're buying a curriculum more than pieces and things like that. But so we'll look at this, particularly when we do I'll create these kinds of plots when we do the inference for categorical variables. This is sort of my precursor when I do a chi-squared. All right, I just want to show another decoration that I often use, which is a chord flip. So this is kind of nice that you could take a whole plot and just rotate it 90 degrees. I tend to prefer my box and whisker plots oriented horizontally versus vertically, in part because I often take a pen on the screen and I'm going left to right to kind of right that I'm trying to compare medians. And to me, it's just a little bit. I mean, I could do it. I could just do the pen horizontally, but I don't know why. I tend to like this orientation. Personal preference. All right. So next, histograms. So this is pretty common. So we clearly see, right, there is a skewed distribution, right? Most sets cost under $100, but there are a few sets that cost more, and it actually made the news. Lego actually just released their first $1,000 set in the last couple of weeks, which is insanity. Um, it's like almost, I think, over 9,000 pieces. It's anyways, I can't wait to see it in the store, but I am not buying it. Um, uh, so this is, so you have this. So the log transformation, right? So we could see here. So I think I have a little bit. I tend to always do this here. So let me start with, so here I'm going to create a vector with values going from 0 to 10 in increments of 0.1. Then I'm going to create a data frame, right? So I have the raw metric, and then I take the log of that metric. And then I could draw it. I can draw the points. I could also do, so just to show, we can do multiple geometries. I can have the path and the points like so, right? And so what I want to show is like, so log of 10 is a little over 2. Now I'm going to increase my vector by an order of magnitude. So now I'm going from 0 to 100. And notice my y, what were we at before? Right around 2, a little over 2. So I added an order of magnitude more points. So I'm going all the way to 100. But my y value only increased to just under 5-ish, I would say, reading that off. I can go another order of magnitude to 1,000. And so it's going to take a little bit longer to draw. Oh, I didn't hit that one. Okay. So now I'm going to 1,000. So remember at 100, I was right around 5, and I'm at like 7.5 or 8 or so. So what a log is doing is it's going to make really big values kind of come down smaller. So the shape of this plot, right? It's going to go asymptotically out, and it's kind of plateauing. So when we think about it in terms of like, a distribution like this that has a long right tail or is positively skewed, when we take the log transformation, it's going to bring it down and be a little bit more normal. You're actually going to play around with this a little bit, and we're going to learn another plot called a QQ or quantile plot in the distributions lab, I think it is, where this is going to be important because a lot of the tools we're going to learn in this course assume a normal distribution, or at least there's going to be a parameter of interest, and that parameter is the normal distribution. Okay. Is there a question? Okay, so we can also facet histograms like so. All right, so Denise asked one density plot. So here I just changed histogram to density. Density is really useful for a couple of reasons. So now We could see from the histogram, right? We have some that have almost no, have far fewer observations, right? Oops. So if we're thinking about it in terms of availability, as I thought, right? So if I do table, Lego sets, availability, um, right? The not specified is pretty large. Retails, you know, and I could pipe this to prop.table. So I could see that not specified is 33%, retail is 36%. I have 12%, then everything is, and then limited is 10%. Everything else is smaller. So comparing these histograms is not really useful because the y-axis are counts. Okay. The y-axis are counts. But when we use density, the y-axis becomes density. The raw metric doesn't make a lot of sense, but when I do the log transformation, I can actually see the shape, right? So the shape is smoothed in a way to do it. So I use density and histograms almost together. Um, so if I'm trying to evaluate the shape of a distribution, I often just use the density because one problem with uh, histograms, right? So if I do the histogram just like this in ggplot, you're going to get this warning message that says stat bins equals 30. What does that mean? It means ggplot took the range of values and divided it into 30 so that there are 30 bars here. And that's almost never what you want, right? It is so context specific what that should be. So in the slides, what I use is I specified bin width. So what does that do? So this is saying each bin, each bar represents a range of $25, right? So then this first bar are all sets that cost between 0 and 25. The second bar is 25 to 50, right? So most sets cost somewhere between 25 and $50. Here's 50 and 75, 75 and 100, 125, et cetera, et cetera, et cetera. So I'm saying each bar represents $20. That makes sense for this metric. It may not make sense for every metric. Or alternatively, is there's a bins parameter. And so here I'm just saying take the range and divide it by 10. So there are 10 bars, right? And so depending on your choice of bins can really change your interpretation, right? Of the value. If I only do 3, that's kind of silly in this instance, right? But remember the default is 30. Oops. Um, so if I go, if I could type there's 39, I mean, I could go crazy. You can do 100 and you're going to see a lot of like little jagged and valleys, right? And particularly when we do that distributions chapter, this could influence your interpretation in terms of the shape. So that gets alleviated if I just say, well, I'm just going to do geom density. I got to get rid of that. And so now it's just going to kind of smooth it out. So when do you use both? I actually kind of use both together, Denise. So if I'm doing one, I'm doing the other. All right, this oops, got really big. I'm just gonna quickly show you, like I said, don't want to overwhelm. We're only doing a few geometries this week, but if you can think of it, it's probably there. This chart is, to me, a helpful way of understanding what you can do. So the X along the rows here are all the different geometry types. So if we go to our good old handy box plot, we have orange squares, blue circles, and green triangles. Yes, that's true, Denise. It gets cluttered, and you oftentimes what people do is they use too many bars and they might think something is bimodal, but it's really not, meaning bimodal meaning it has two peaks. So yeah, there's some challenges with histograms. Okay, reading this plot. The blue circle, right? Oh, and then the columns correspond to the what could be in the aesthetic, right? The AES. So if it's a blue circle, that means that geometry. So a box plot almost always will have an X and a Y specified from the data frame. Okay. The orange or yellow squares here means these different features can be in the data or outside the data. Okay. What do I mean by that? So for, let's see, where you have geom point. Okay. So I showed color, right? Inside the aesthetic, right? Oh, where's my RStudio? Okay. So here, oh, I took it out. It's this one. Um, right. So I have color inside the aesthetic. So when it's inside the aesthetic, I'm saying I want that feature mapped to a variable in this data frame. Now, alternatively, the color can be outside the aesthetic and just in the geometry. And so what this did is just make every point purple. Okay. Which is fine. So the story I always like to tell a long time ago when I was creating a fact book at my previous job, several jobs ago, a president called me up, right? I created this report and said, I was doing something like this, right? He called, I want that plot in color. And I'm like, what do you mean in color? Like, it's kind of in color. I mean, I know it's grayscale, but it's a color. I was like, what do you want the variables colored by school or degree program? He's like, no, I just wanted, the color. I was like, what color? He's like, you know, purple. College is purple. So this is what he wanted, right? He wanted the figure when he put it into his slide deck to be the same color as his PowerPoint theme, right? And anyways, so you can do that if you want. But I remember because I got on the phone with him. I was like, I don't understand because I'm thinking color mapped to data, but he's like, no, I just want the colors to, match our marketing theme. So, all right, Likert scales. Um, so if I've written a package to kind of handle this because I have sort of strong opinions about how Likert data should be represented. Um, a lot of people just convert them to numeric variables. So we could have strongly disagree, disagree, neutral, agree, strongly agree, right? The typical agreement scale. You've probably taken those forever. You've taken it in this class. So what a lot of people would do is say, okay, strongly disagree is 0, disagree is 1, neutral is 2, agree is 3, strongly agree is 4, right? I think I did that right. The problem with that is now you're assuming that the intervals are equal, right? Because 1 minus 0 is 1, 2 minus 1 is 1, right? Et cetera, et cetera. But when people respond to Likert response data, they're not thinking about it as equal intervals, right? When I respond to a survey, at least, right, I'm at, say you're asking me, do I like statistics, right? Well, I'm not neutral on that. No, I agree. I like statistics, right? But do I like statistics enough to say strongly agree, right? I need to really like it, right? So that weight to go from agree to strongly agree is the evidence or whatever has to be greater than going from neutral to agree. And so because of that, I believe the intervals are not equal. And so using them as quantitative variables is not always appropriate. So I'm looking at a data set here. This comes from the Likert package. This is data from the Program of International Student Assessment. This is a great data set for data projects. There's a lot of really good stuff. It's an assessment done every 3 years, assessing 15-year-olds in their skills in reading, math, and science. But they also have questionnaires. So this is a questionnaire. These are questions on their attitude towards reading. And first thing I'm doing here is just showing the rename function, which I absolutely love. So when you load the data frame from the website, the variables all have this format, right? So it turns out ST stands for student. This is question 24, and question 24 had 11 parts, right? 11 sub questions. So that's not really helpful to me, so I have to rename it. So ST24Q01 was I read if I have to, right? That's what the student was asked. And by the way, this is done in 30 some on countries, but I'm just looking at some questions from North America. So I can pass that data frame to the Likert function, and I could call summary, which is not terribly interesting, but really what I think is really useful is the plot function. So this is available to you. I like it a lot. You can dig in. This is really just a wrapper to ggplot. This is a ggplot expression where I actually have multiple two geom bars. You could see I've colored by, the actual response. There's some tools in there to change your centering or anchoring. You can have it not centered if you want. I'm using geom text on the margin so I can kind of get the marginal percentages. So I could see I like to express my opinion about books I have read. Well, 59% responded on the positive side of the scale and 41% on the negative scale. Right. And I think this is a really kind of a nice way to represent Likert response data. Okay. Last little topic. Somebody want to try to tell me if there's a difference between these pie charts, and if so, what it is? Any brave souls? Can you see anything?
Well, the red kind of increases from A to B and to C, for example.
And green
Okay.
also.
Green is increasing. You think green is increasing? Okay. Anything else?
Black is decreasing from
All
A
right.
to B, C.
I think the circle is increasing.
Circle's increasing. Oh, well, that's a new one. You might that could be you could be seeing that. What if I show it this way? Is this a little easier? Can you see what's going on here? So I have very, very few absolutes in my life. Literally, my job is to measure uncertainty, right? That's what statisticians and data scientists do. We're quantifying how certain we are something is true or not. And rarely do I encounter where something is always true or always false. But I've been doing this a long time. Here is one truth. Don't ever use pie charts. This quote by John Tukey from the last century, I think nicely summarizes it. I've not seen an exception, right? And I've had students send me the cute ones like the pyramid where there's sky, no sky. If you don't know that one, you can Google it. It's cute, but quite honestly, you would be able to interpret it better if you want to know the sky to pyramid ratio. Bar would be better than the pie chart. So, at least in this class, don't use a pie chart, but I encourage you to reject them outright. When you get to the data visualization course, I think you'll dig into a little bit of there's a huge body of perception literature in terms of how the human, eyes and the cortex and all that kind of receive data and stuff. And the pie chart is like hitting on all the areas where the human eye doesn't see things. So the person who said it looks like circles are getting bigger. Yeah, I mean, for some people that could be it. Right? So when you're looking at the pie charts, you're trying to compare non-rectangular areas, often with categories that aren't adjacent. You're doing arc angles. It's like a lot going on. A bar, you're just measuring length. The color is actually unnecessary here in the bar charts. It's just here to map it up, right? I could eliminate the color and then it would be even to me a little bit better of a bar chart. And you're just measuring the heights, one dimension. Our eyes can do that actually fairly effectively. So, anyways, I'll stop belaboring the point, but just don't use pie charts. Somebody uses it in their project presentation, and I will deduct a point for doing so. So just don't do it. Hint: there may be a question on the midterm that students. I'm going to get really explicit because this has been in multiple semesters where I look at the item analysis and I'm like, oh, why? So a bunch of people got, and it's a pie chart question. Yeah, the answer is never, 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 ever. Here are some resources. So this will be on the website once I post the slide deck. I think these are all already linked there, like the R for Data Science book, the ggplot website, fantastic reference. The R graphics cookbook I think is really neat because it's it's designed like a cookbook. So you got this visualization and it breaks down. Here's the recipe to create this, right? As you get more sophisticated. Goal tonight is just to kind of give you a sense of the framework and sort of some of the basic plot types we're going to use in this course very frequently. We'll build them up more and more. I have some actually more complicated ones that I've created to try to explain things, and you can dig in and look at those as well. Yeah, Rebecca, that's right. Looks like pie chart. Yeah, rotating. Yeah. So that sort of is like a crash course in ggplot. I suspect you're going to use it a lot. You can ask questions in the Slack or email us. Happy to do it. I feel like I've been using it quite a lot. Like I said, I use it literally almost every day to do different things. There's a link to the 1 minute paper. I'm happy to answer questions. Poor Angela has heard me do my pie chart rant. How many times now? 100? 150?
It never gets old.
My family even knows about it. Like they'll see a pie chart and they're like, "Uh-oh, Dad's gonna get angry."
Did you bring it up to your wife on your first date?
No. That would be funny. Yeah, so everybody here who's paying attention got a free point. We haven't replaced that question because it still surprises me. So I mean, I could go. So somebody's, why are they so popular? That is a very good question. I think so. There's another person you will become aware of, I think, in the visualization course if you haven't already. Edward Tufte. If you're doing data visualization, you need to know his work. He has a lot of principles on visualization, like his this is sort of considered the Bible, the visual display of quantitative data. Like this is, if you're a data visualization person, you need to have this book. And it's also beautifully printed. So he has this notion of chart junk, which is the ratio of ink to information. And so Tufte just said, he rightfully said there are better ways, right? And then, like I said, there's perception literature and things like that. But Tufte says you're using more ink, like the bar plot gives you the same amount of information, if not more, with less ink, right? So he's always looking at the ink to information ratio. So so it's kind of like chart junk. So when people build dashboards, right, you see that's where I see pie charts used a lot. They often want to use more real estate and don't care about the information they want. They're just trying to fill space. Like the more, sort of the bigger the thing is on the dashboard, the more important people think it is. That's my hypothesis, at least, as to why people think it's popular. Where the bar chart would just give it I don't know, maybe the bar chart is a little bit more sterile. Even worse is the 3D pie chart, which was popular in Excel. I haven't seen it in a while. Those are even worse because the areas then are distorted so that the comparisons aren't even really valid. So that's my attempt. No pie chart, Tony. You could just have one bar if it's all one.
So there's never ever a time where you would want to, because I know that some people say, like, if you have more than, let's say, more than 5 things to compare, maybe that's okay if you're like looking at percentages and how much of something. I mean, I know not to use it in your class. I'm not going to use it in your class. I just want to know.
I still think you should just use a bar plot, or there may be something else that's better, but generally a bar plot is a better one. Yeah, I've like I said, I've been doing this in some form or another for decades. I haven't seen an instance where I think the pie chart is appropriate. And I will, in a couple of weeks when we do z-scores, I have another plot type. I used to do it here, but I moved it until later, where but I was a little bit more hesitant. I was like, don't use this chart type. But it's not like literally, this is an absolute. I haven't found a place where a pie chart is appropriate. On this other one, I have conceded that under certain circumstances, and if you do it in a certain way, you can do this, a dual scales chart. It's common in the finance world where you have, two lines. One represents like dollars and one represents, weight or volume or some other metric, right? And so that is problematic, but there's a path to making it useful. And we'll talk about that. 2 weeks, I think, maybe. Any other questions? Oh my God, yes. Yes, Rebecca. So, I almost want to. If I go here, let's. Can I do that? So I got my big screen. So if I make this a little bit smaller, I think I can do. All right, let's do that. We got 12 minutes. I mean, if you need to drop off. So I'll create a new, I'll call it birds. We're going to do data frame. This would probably be easier in a Tibble, but I'll do it this way. So we're going to start with collisions with vehicles, poison.
But is it always recommended that log be used or only in certain circumstances? Like I'm just trying to wrap my head around like today.
Just not a pie chart, usually a bar chart.
Yeah, log when you were talking about that.
Okay, yeah, that's a good question. In terms of transformation, if it's right skewed, log is usually what you want. We're actually going to talk about this when we get to the distributions chapter. So log works really well for right skewed, which is the most common way data is skewed, right? If you think about financial data or salaries or revenue or anything like monetary, there tends to be like outliers, right? And so the log is going to bring that down to look a little bit more normal, right? As they get extreme, it's making those intervals smaller out on the right-hand side. But if you have other kinds of skewness, log might not work. And that's when I usually consult Google. Like left skewed is one of the biggest challenges we have because we tend to look at like GPA, okay, where you have a lot more, students in like the 3 to 4 range. And then as you get lower GPAs, you have fewer. So the skewness is kind of mirrored. But what we often do when we really have to do a transformation on that, because GPA is bounded, we could do 4 minus, which is basically mirroring you can mirror it and then do the log transformation on that. But then you have to interpret it that lower values are higher GPAs. So your interpretation, the signs are going to be reversed. If you have a left skewed that's not bounded, where you don't have a maximum value that you can use to mirror it, then it gets a little bit tricky. Then there's Angela, you did some digging. There was like a lambda transformation you found like
Up.
honestly, it happens so infrequently when we encounter it, we have to go Google it or like look in the literature and see what works.
Yeah, there's also a box Cox one, I think.
Oh yeah. I forgot about that
Yeah.
one.
When would you use log base E?
Oh, when log base 10 didn't work. I'm sorry, but transformations are hard. It's like, honestly, we usually just use base 10. But you could use it shouldn't matter, right? You're just using instead of 10 to a power, you're using Euler's number, which is what 2.6. Is this how I get it? Yeah, 2.7182. So EXP1 here is Euler's number. But I think you can do, I think the log. Oh, you know what? So one I did earlier was log of Euler's number. I have to do log 10 if you want the base 10 log transformation. You can also do a base 2. If you're like in binary or something, you could do that. All right, I want to just finish this up in the 7 minutes. So call value. So I started here. So I have 2145. Oops, 214,500. Oh, I hope I did that right. 72 1. Wait, okay. Explain this to me. Is this a typo? Should there be another 0 there? No, because that sliver would be smaller. So I think the numbers are right, but the commas are wrong. Do you guys see that? Okay, then I need 6250. I hate doing data entry. 328. 676,500. 1, 2, 3, and then cats. I really loved this. 507. Okay, and I have 1 collisions with vehicles, poison, collisions with electrical lines, electrocution, oil pits, collisions with turbines. Oh, okay, I see. I forgot collisions with building glass. Okay, so now I can do ggplot birds AES x equals actually I should have called this death. And no, deaths are category, I guess. Okay, so X is category, Y equals deaths. I could do geom bar. Oh, right, I have to say stat equals identity here because it's pre-summarized data. And I have to spell it right. I think that's a nicer looking. I must have a number typed in wrong because no, I don't. Wait, let me see here. 21500 123. Yeah, I did. There we go. Right? Cats are the leading cause of death for birds by a factor of more than 2, right? So not only can I see that, I could see that. Oil pits is almost. Is this real data? Who shared this link? I'm gonna
Yeah, it's from the New York City Bird Alliance.
this is awesome. So I'll throw this in. Now, I'll show this like just my thinking on this. Because those categories are big, if I do chord flip here. All right, now I can remove those here. I'll just do this as an exercise. Then I might do Y lab. I'm going to get rid of the Y. Oops. Right, because it's before the flip. Right, so I got categories kind of unnecessary here. Then I think I mentioned I like let me see here. Theme. That's fine. Well, can we find a we could go, I mean, if you want to get crazy, ggplot2 fun themes. There is an XKCD. Where's the XKCD? XKCD ggplot2 theme. What package is that in? Oh no. It was archived?
Yeah, it is archived.
Bummer.
I checked that a while back actually.
What's the
It still works actually. I mean, like if you have it installed.
yeah. XK, is it on GitHub by any chance?
Yeah.
Oh, there's a Vegas themes. Oh, it's not there.
You can
all right.
also install it from the archive on CRAN if you want.
Oh yeah, I guess I could do that. All right. Well, I'm not gonna bother. I'll just do my typical theme minimal because I'm boring. All right. Then what else would I do? Y lab number of deaths, right? Oops. See how I can kind of start playing with this? I don't know. I think that's better than pie chart. It is technically possible to do pie charts in ggplot, but it's really hard. You have to actually convert to polar coordinates. And if you don't know what that is, good for you. You don't want to go there. I'm sorry, I'm being punchy tonight. Any other questions? I'm sorry, did I miss anything? That bird data set is going to make it into the course now. So thank you, Rebecca. All right. Well, that's very cool. There's another data set that I haven't incorporated that I should. Somebody did a project on there's a squirrel census done in New York City.
Uh-huh.
That was a pretty cool one too. That was neat. Might be related to your work, Rebecca. Oh, and thanks, Monsieur. Yeah, this is. Yeah, I definitely want that. I just can't remember how to install our packages that have been archived. I think you have to give the direct link to the source file, if I remember. All right. Well, have a good night, everyone.
Good night.
Next week.
Thank you. Good night.
Thank you.